Okay, on each of these questions we're going to have to draw two sets of axes to see how this transformation affects each of two vectors. So draw some axes. They don't have to be to any particular length. That's y and that's x. And we have a centre which we call 0. We need to do that twice, as I said. Again, it doesn't matter if they're both the same, it is just as a visual aid. Y, x and 0. And we are going to draw on a vector on each one. Now the vector starts at the origin in each case. One of them is 1, 0, so that means 1 along and 0 up. So that is going to look like that. Now the other one is 0 along and 1 up, so that is going to look like that. So those vectors again, 1, 0 and 0, 1. Right, we're going to move interchangeably between vector notation and coordinates. So the vector 1, 0 takes you from the origin to the coordinate 1, 0. So these obviously look very similar. This vector here takes you from the origin up to 0, 1. And again, 0, 1, 0, 1. They look very similar. Right, we're now going to perform this transformation. So we're going to do a reflection in the x-axis. So that line there, if we reflect it in the x-axis, isn't actually going to do anything. It's going to be in exactly the same space, in the same place. This one, however, is going to reflect from here to here. So it is going to go down to that coordinate there. Now that is the coordinate, if you think about it, this is 1 up, this is going to be 1 down. So this is going to be 0, negative 1. This one here is going to still be in 1, 0. So your coordinate here, sorry, your vector here has been transformed from 1, 0 to 1, 0. And your vector here has been transformed from 0, 1 to 0, negative 1. So the question says work out the matrix that represents each of the following transformations. On this one we take this vector here and put it in here, and we take this one here and put it in here. So that is the matrix that reflects those two things into the in the x-axis.